Advanced Algebra through Data Exploration Study Guide for Unit 3 test. If I go too fast, ladies and gentlemen, please feel free to rewind or pause it. Here we go. An article on Honda in Consumer Reports, September 1990, reported the following average miles per gallon. Okay, here is our data. Construct a stem and leaf plot of the above data. I have it started already. The stem is on the left. The leaves will be on the right. The smallest gas mileage is 18. So our stem will begin with an 8. I'm sorry, our stem will begin with a 1. Our leaf will be an 8. And that's the only one. Okay. Looking for our largest gas mileage is 50. So our stem is going to go from 1 to 5. All right, now we're going to fill it in. Remember to go from smallest to largest. All right, I've already gone through this and put them in order, so I'm just going to fill them in very quickly. Again, if I'm going too fast, pause it, fill it in, and then check your answers when we're done. Here we go. All right, I don't think I missed any, but it's very possible that I did. So these are all of the gas mileages in a stem and leaf plot. Remember, we have to make a key. You are the author of this stem and leaf plot. Anyone who is reading that stem and leaf plot needs to know what it's about, so we need a key. Pick any number you want. I usually pick the first one. All right, there's my key, 18 miles per gallon, and this is for Hondas. Stem and leaf plot. All right. Construct a box and whisker plot. Make sure to draw the numbers on the line and to also label the 5 numbers on the box plot. Now, I already filled in the number line, okay, based on my numbers. 18 again was my smallest, so I'm going to want to begin with 15, and I'm going to count by 5s. 15, 20, 25, 30, 35, 40, 45, 50. I'm going to stop at 50 because that's my largest number. Now, using the calculator, I have already put those in my list, stat edit. Okay, I already typed all the numbers into my list. You do not have to put them in any order. Okay, they are all there. Then I'm going to do the stat, right arrow calculate, and I'm going to pick number 1, one variable stat, and I'm going to hit enter until the numbers pop up. I'm going to scroll down, and here are my 5 numbers that I want: 18, 25, 35, 41, and 50. Okay, so I'm going to go ahead and put that on and make a stem and leaf plot out of that. The left side is a whisker, the right side is a whisker, and then the box is in the middle. Again, those are the 5 numbers. Okay, down below, find the mean and the IQR. Well, the mean, if I scroll back up, ladies and gentlemen, okay, remember the mean is the very first one right there, the X bar. So our mean is 33.63. And that would be miles per gallon. Not too bad for Honda, 33.63 miles per gallon. The IQR, remember, is taking your Q3 minus your Q1. So in this case, that would be 41 minus 25, which gives us 16. All right, there we go. That is page 1. Let's go on to page 2. There we go. Page 2. I went too far. All right. Page 2. Use the picture to answer questions 4, 5, and 6. What is the dot called in the picture? Okay. Remember that is called an outlier. Which way is it skewed? Well, the outlier is pulling it to the left. Which side of the median would the mean fall? Okay. It would be on the left side because it is skewed left. Remember, the smaller value or values will pull the mean down. All right. Number 7, label the 5 parts of the box plot. All right. Well, we just went over this on the front. This is our minimum. This is Q1. This is our median. This is quartile 3. And this is our maximum. What percent is each piece of the box plot? Well, each piece, both whiskers and then inside the box, each piece is 25% of the data. That will never, ever change. So 25%. If the box plot represents 80 values, how many values are in the lower whisker? Okay, well, if 80 values, take your 25%, change it to a decimal. So 25% of 80 is 20. So there's 20 values in this whisker. That means there's 20 values here, there's 20 values here, and there's 20 values here. Okay. If the box plot represents 50 values, how many values are in the whole box? Well, the whole box is 50%. Change that to a decimal. So basically, what is half of 50? Well, half of 50 is 25. All right, let's keep going. Get the pages right this time. All right, number 11. Face it, a hot dog isn't a carrot stick. So said Consumer Reports, commenting on the low nutritious quality of All-American Frank. Because people are concerned about their health, may prefer low-calorie hot dogs, we ask, are there any systematic differences among the two types of hot dogs? Use the box plots to answer the question. Here's our meat hot dog information. Here's our poultry hot dog and the number of calories. Okay, here's the box plot. Everything is already plotted for you. So it says, what does the data show about the two different hot dogs? Look at the box plots. Well, there's several things you could say. You could mention the meat hot dogs, or you could mention the poultry hot dogs and compare them. I don't care which one you begin with, just make sure you get the wording right. So I'm going to go ahead and say the poultry hot dogs have fewer, because it's to the left, calories compared to the meat hot dogs. Okay, you could reverse that and say the meat hot dogs have more calories compared to the poultry hot dogs. Okay, either way would be fine. All right, moving on. Number 12. Here is our histogram. Now, technically, there shouldn't be any gaps between them, but this is one that I pulled off the internet somewhere. Okay, there shouldn't be any gaps. They should be touching each other. All right, which way is this skewed? Well, it is skewed this time to the right. Okay, which side of the median is the mean on? Well, the right side. because it is skewed right. The bigger values will pull up the mean. All right, let's keep rolling, ladies and gentlemen. All right, create a histogram of the following data. Okay, an article on Peanut Butter Consumer Reports reported the following scores. So we got some scores of creamy. Now, you could count your scale, your x-axis scale, you could count by 5s or 10s. I decided to go by 5s. You can certainly go by 10s if you want, 5 or 10s. Okay, now I've already counted these up and I know how much many go in each bar. So there's one number from 20 to 25. Okay, there are two numbers from 30 to 35. So there's a gap here because there's no numbers between 25 and 30. Okay, there are two numbers from 35 to 40. There are four numbers from 40 to 45. And again, if I'm going too fast, pause, fill it out, and then continue. Okay, 45 to 50, there is only one. Okay, 50 to 55, there should be four again. 55 to 60, there should be three. 60 to 65, there is only one. And then this last one has two. Okay, not the neatest. Hopefully you do a little bit better job than I did with that. And then this is the frequency. Okay, and then this is peanut butter score. Okay, so make sure you label your X and Y axis. All right, moving on. How many people does this histogram represent? Well, the first thing you should do is go ahead and write what's on each one. So this is 2, this is 10, this is 5, this is 2, and this is 1. So if we add all of those up, we should get 20. What percent of people ride the bus? This is where we make a fraction. 10 to 20 minutes, okay? That would be 10. So we're going to go 10 divided by the total. That's going to give us a decimal. And then we're going to change that to a percent. 17. What percent of people ride the bus more than 30 minutes? Okay, that would be 3. Out of 20. That should give us a decimal of 0.15, which is 15%. In what interval is the median? Remember, median means middle. Well, halfway between half of 20 is 10, right? So we're going to go to the 10th, 11th one. So, well, if we count, here's 2, this gets us to 12. So the 10th and 11th person is going to be in this bar. So our answer is 10 to 20. That's the interval that the median is in. Okay, think about it, rewind that, listen to what I said again if you need to. Okay, if we were to find the mean, would it be smaller or larger than the median? Okay, it would be larger. Because it is skewed right. Okay, again, it is skewed to the right. If a person riding the bus is in the 80th percentile for time, at what interval will that person be? All right, well, we have to take 20, multiply it to the decimal for the percentile, and that's going to give us 16. So we want to find the 16th person. All right, well, we have to count. Here's 2 people. This gets us to 12 people. This gets us to 17 people, which is more than I need. So the 16th person has to be in this interval 20 to 30. All right, well, let's keep going. Okay, last page. Use this information for these 2 problems. This is a sample of 10 automobiles and the fuel efficiency. So 30 miles, 28 miles, 28 miles, 29, 22, 18, 36, 32, 30, 27. Okay, the first thing we want to do is we want to find the mean absolute deviation. All right, well, step 1, we want to find the mean. So we need to take and put those numbers in our calculator, which I have already done. There they are. Okay, I didn't want to take time to type those in. Okay, so I typed in all of those numbers. I went stat. I went calculate. I picked number 1. I hit enter until the numbers show up. And I see that the mean is 28. So the mean is 28. Find the difference of each number. So that's where I take and subtract the mean. Notice I already filled out this table to save time. I subtract the mean from each number. Again, pause this and fill it all out and then continue playing. All right, so the difference here is 2. The difference here is 0, and 0, and 1, and -6, and -10, and +8, and 4, and 2, and 1. Okay, but remember, absolute value would be positives. So all of these we want to be positives. 2, 0, 0, 1, +6, +10, 8, 4, 2, and 1. Okay, now what we need to do next is we need to add all of the numbers up. So the sum of all of these numbers, if we add those up, is 34. Okay, but to find the mean, we then take that sum and divide it by 10 numbers. There's 10 numbers here. And so we get an answer of 3.4. Okay, the next one is standard deviation. Everything is the same except for the last 4 steps. Okay, so I'm not even going to fill this part out. I'm going to go ahead and put my positives down this one. Because what's different? Okay, I have to, well, actually step 3. We have to square the numbers. So we're going to square these. 2 squared is 4. 0 squared is 0. 0. 1 squared is 1. 6 squared is 36. 10 squared is 100. 8 squared is 64. Okay, again, we are squaring the numbers. This would be 16, this would be 4, and this would be 1. Okay, then we're going to add up all those numbers. Okay, we're going to add them all up. When we add them all up, we get 226. Now, this is the part people tend to forget. Divide the sum by one less than the number of numbers. So 226 divided by 9. 10. 10 take away 1 is 9. Divide by 9, not 10. And you get 25.11. And then take the square root of that number. So we're going to take the square root of 25.11 and we get 5.01. So the standard deviation is approximately 5.01. All right, and then the last one, look at the two data sets. Which one will have a higher standard deviation and why? Well, when I look at this one, I see it goes from 18 for the smallest to 24. Okay, that's not very far apart. This one goes from 8 to 61. Okay, well, that's really far apart. This one's not that far apart. This one's really far apart. So we have to say the higher standard deviation will be from data set 2 because the numbers are more spread out than data set 1. All right, that's it, ladies and gentlemen. Good luck on your test.